We are first-year engineering students at the Duke University Practical of Engineering. We are Mona, Richard, Jolie, and Tess, and today we will be presenting our design solution, the hand tremor stabilizing device, for our client, Kate.
Kate has ataxia, which is a neurological disorder that causes tremors in her arms and hands. Currently, because of these tremors, she can't use her iPad on her own. She needs a caregiver to stabilize her arm. Our client, Kate, wants a device that allows her to use her iPad independently. Our device allows Kate to be more independent, and it eases manual labor for her caretaker.
We had two design blocks. One of our design blocks was to stabilize Kate's tremors. The handlebar achieves this design block. Another design block we had was to stabilize the device itself. The clamps help achieve this.
Our device is mechanical and concentrates her force on her grip of a handlebar. Kate's firm grip reduces her tremors enough for her to use her iPad independently. The handlebar grip is a 3D printed handlebar that allows Kate to grip an object to stabilize her hand, with a finger support to let her rest her index finger. It's 3D printed because the plastic is light, durable, and easy to make with precise specifications.
The handlebar rests on two springs, which enable vertical movement. Two rods support each spring. The two rods are then attached to a drawer slider. They are 2 by 10 inch 0.06 pounds per inch springs, which means that Kate only needs to exert 2.4 pounds of force to compress both springs fully. This force is weak enough to prevent straining Kate's arm for prolonged use, but strong enough to stabilize her tremors. The springs are made from stainless steel to avoid corrosion and therefore increase long-term durability. They are on rods that are made of metal, since metal is rigid and durable, so they will firmly support the handlebar. These rods are threaded, so we can cap the top with a nut and drill the bottom into a wooden base. We chose a wooden base because wood is light and durable enough for our needs. The wooden base was then drilled into the drawer slider.
The drawer slide allows horizontal motion. The slide was drilled into three 30-degree triangular wedges, which were then drilled into a wooden base. The reason we angled the wedges at 30 degrees was to make the rods angled at 60 degrees to the table, which makes them parallel to the 60-degree angle of the iPad. Thanks to this angle, Kate's hand will always be parallel to the iPad for convenience. The handlebar was printed with a 30-degree cut, so it rests parallel to the table. That way, Kate's wrist is always relaxed too. This base supports the drawer slide as Kate can move the slider horizontally.
Clamps are used to attach and stabilize the iPad to the table. As you can see, they are clamped to the extensions so that the clamps do not interfere with Kate's legs, while the hinges allow the extensions to fold neatly to make the device more portable.
Setting up the device is very easy. You just unfold the two wooden extensions, rest it on the table with the grip facing the correct direction, and clamp it to the table. Then you're ready to go.
Springs rest on rods that are drilled into a wooden base. The handlebar rests on top of washers that rest on top of the springs, not to prevent the handlebar from going off. The wooden base is then drilled into the drawer slide, which is drilled into the three triangular wedges. The triangular wedges are then glued to the wooden base. Hinges attach the wooden base to each side.
Our design meets our first design criterion. Kate can access the entire 9.45-inch by 6.67-inch screen of her iPad. We tested this by seeing how much of the screen area she could color, and she could color about 80%. The device met the second criterion of stabilizing her tremors, which we tested by seeing if she could tap the four corners and the center, and if she could write her name, all of which she could do. We could set up our device in less than 30 seconds, which fits our third criterion. The following design criterion is comfort. Currently, there still needs to be further prototyping of handlebar grip to ensure that Kate's pressure does not cause pain or discomfort while holding the grip, since it is 3D printed plastic. She rated comfort as a 2 out of 5, uncomfortable but still usable. The device meets our last design criteria of durability, since we dropped the device from 3 feet and it did not break multiple times.
In the future, we want to add a silicone grip to the handlebar to increase comfort for Kate.